Okay. All right. So let's go through some of these here. While you were working on the first example, I did kind of modify some of these so that, well, you'll see what I mean. Oh, wait, I got to share it. I can't see it yet. Well, here it comes. Here we go. Okay, so for the first one, again, notice that we can't factor out x, mostly because there's a non-zero constant term. It should be constant term. Let me fix that. This is a non-zero constant term. That's what it should say. Okay? And because of that, we can't factor out x at all. Basically, there's a term with no x's in it. So we can't factor out x, the variable. Since there's a coefficient of 1, you're not able to factor any numbers out, right? Because remember, you would factor out the greatest common factor among the coefficients and the constant term. But as we see here, though, because of the 1, the only common factor among the coefficients and the constant term is a 1. So we can't factor out anything except 1, meaning the GCF is 1. In other words, the m would be 0. There's a non-zero constant term. And since there's a coefficient of 1, the only common factor is 1 among the coefficients and the constant term. So your b would be 1, hence the GCF is 1. So we form our two groups, right? So for the first two terms, okay, the smallest exponent of x is 2, okay? So x squared we will be able to factor out. Also, we have 8 and 64, and 8 is a factor of 64. In other words, the greatest common factor among 8 and 64 is 8. So the GCF then is 8x squared. Because of that, we can factor out 8x squared, and when you divide, right, you divide into each term, we get 8x squared times the 8's cancel, x cubed over x squared, we get x, minus 64x squared over 8x squared. Now that's for the first group. We get 8x squared times x minus 8. So that's what we have so far. Okay. For x minus 8, you can't factor out anything because, again, there's a non-zero constant term here, right? We have that 8. That doesn't have x's in it. So you can't factor out x. We have x over here, right? But the coefficient is 1. So the greatest common factor among 1 and 8 is just 1. So the GCF is 1. Okay. Okay, so the GCF is 1. So x minus 8, we just leave alone. So if you go back to the polynomial with the groupings, right? What we did remember was for the first group, we can substitute this, the 8x squared times x minus 8. But x minus 8, you could pull out in front. And that's what I was modifying while you guys were working on the first example. Originally, I had all the steps here. But I think it's easier. It appears that people are less confused if I just show this. So, right? Because if you take the x minus 8 and you pull it out in front, right? If you pull this away, you're left with 8x squared. Here, if you pull x minus 8 away, there's nothing left, but you have to put a 1 there. I mean, really in the background, what's happening is we're dividing. Okay. Oh, sorry, made it worse. Never mind. So I tried to fix that, but, well, it's not wrong, but I thought it would look nicer. But anyway, what's really happening is you're dividing. Okay? So Either way, this is what we get. All right. Are there any questions on that? All right, let's do the next one. Down here. Okay, so here, let's look. Okay, so again, there's a term with no x's in it, right? A non-zero constant term. Okay, so what does that tell us? Well, we can't factor out x. We can't factor out a variable at all. So the GCF is not going to have x in it. Or in other words, m is going to be 0. Now, for the coefficients, you could list the factors of all the coefficients and the constant term. You could. But if we look at 2 and 5 alone, what's going to happen? Well, 2, the only factors of it are 1 and 2. The only factors of 5 are 1 and 5. You could list the factors for 12 and 30 as well, but right away you can see what's going to happen. The only factor in common with 2 and 5 is 1. So the only possible factor in common with all the factors of 12, 2, 30, and 5 is 1. It's the only factor in common is 1. With the constants term and the coefficients. So the GCF, there's no variable. The greatest common factor among the coefficients and the constant term is 1. So the GCF is 1. We don't factor anything out, in other words. All right. So now we can make 2 groups, right? The first 2 terms go in a group. Note, though, that between the second and third term, it's always good to have addition. So I changed this to addition. That is, I rewrote this as adding the negative. And then the third and fourth term, I put in a group. You always want between, okay? Between the second and third term, this is subtraction, right? But I've said it before, we want this to be addition. So you have to write it as adding the negative. And then, okay, for the first group, the smallest exponent of x is 2. 2 is also a factor of 12. So basically, we're going to factor out 2 times x squared. That's actually the GCF, and that's what I'm doing here. You know, when you factor it out, right, you have to divide to see what's left over. And when you do that, you're going to get 2x squared times, for the first quotient, 12 over 2 is 6, x cubed over x squared, that's just x. 2x squared over 2x squared, that's just 1. For the next group, I want to be able to finish this. For the minus 30x minus 5, well, there's a constant term here, so we can't factor out x at all, meaning the smallest exponent of x is 0. 5 and 30, well, 5 is a factor of 30, so 5 is the greatest common factor of 5 and 30, so 5 is the GCF. But remember, if you go back to the original, the second term has addition, the fourth term has subtraction. So you have to factor out negative to GCF of the second group. You have to take out a negative, and that's what I'm doing here. I'm not factoring out 5, I'm factoring out negative 5. When I do that, 6x plus 1 is a common factor, and 6x plus 1 we pull out, and when you do, this is what you get. You could leave it as 2x squared plus negative 5. I just wrote it as minus 5, 2x squared minus 5, but both of them are right. We're out of time now. I will post this on Blackboard, though, okay? I mean, I really hope that makes sense, so, okay. All right, I do have office hours at 2.